Greetings, my structural analysis friends. Now that we've kind of discussed the basics of gravity loads, such as dead and live loads, we're going to start to turn our attention to environmental loads, loads that come from the surrounding environment, right? Things like wind and snow and rain. And in order to do that, we have to be able to talk about some of the basic factors that are common to all of those. So that's what we're going to do today. So without further ado, let's get started. So we're going to define environmental loads as being loads that include snow, wind, seismic, and other effects. We've mentioned rain that can that affect buildings in different ways. Some cause loads to be horizontally, or what we call lateral loads. Some can cause loads to be vertically, which is kind of like a gravity load. But sometimes they can even cause a load to act upward on a building, opposite of gravity. Okay, and then of course seismic can kind of do whatever it wants. We won't do a lot with seismic in this particular course, but for the others, it's some basic fundamentals that we need to kind of talk about. All right. Now, some of the variables that go into defining environmental loads that are common to all of these are the category classification of the structure, the importance of the building, and the exposure characteristics. And so in this video, we're going to talk about each of those and kind of what each one of those means. Again, all we're doing with this load definition is we're referring back to the requirements of ASCE 710. And we're going to kind of define those. I'm going to show you where to find the values that give you those factors, or where to find that information. That's the purpose of what this video is. The actual calculations will come in a later video after this one. So please stay with us. All right. So the first one that we want to talk about is what we call the risk category classification, okay, in ASCE 710. Okay, this is table 1.5-1. And what you can see is that buildings are broken down into 4 basic risk categories. Now, risk is defined as being kind of the effect of, or the importance to people at the time of the incident, whether it's a big snow load, whether it's a category 5 hurricane or something. The risk category is basically measured in terms of the risk to human life. All right, so the categories are declared as 1 through 4. That's these Roman numerals that are here on the right. Okay, and then this table contains the basic definition of our building. Okay, and so what we'll do is we'll kind of read through a couple of them and give you kind of a sense of what these structures are and what category they would fall in, but realize that there are no hard and fast lines. It's not like, oh, if I have 500 people, it's category 3, but if I have 499, it's category 2. There's kind of a gray area. So again, we're coming back on this engineering judgment in order to be able to establish that. And so you have to be able to design your building for whichever category you think is the most appropriate, whatever lets you sleep at night, so to say. All right, so without further ado, we'll get ourselves going here. Okay, so category 1 is basically buildings and other structures that represent a low risk to human life in the event of failure. Okay, so things like ag barns or mining facility or something, low personnel operations could be considered as a risk 1 category. It's not like when the event occurs that the building is going to fall and it's going to trap a lot of people underneath the rubble. Now, again, we don't, hopefully our structures never fall down. That's, obviously our primary goal, but, should an unforeseen disaster happen, that's kind of what we're thinking. That's the logic or the mindset that we're trying to work with here. Okay. We're going to skip category 2 because he's kind of the catch-all for this. Okay. This is all buildings and other structures except those listed in categories 1, 3, and 4. So if you can't find a good category or know a good reason to put it in one of these others, we're going to go down and we're going to call it a 2. Okay. All right. Let's jump down to risk category 4. Okay. And so buildings and other structures designated as essential services. Okay. Things that are needed in times of disasters, or if something happened to the structure that would cause a significant impact on human life around there. Examples of this might be hospitals, right? If you have a disaster, you need to have the hospital facilities open and running to be able to accommodate all of the people that are going to be needing help on those. That would be kind of a category for building. On the other side of that would be something like, say, a nuclear reactor, that if there were ever a problem with that structure, that it broke or malfunctioned or failed, that, it could expose large areas of people to, to the effects, whether it's radiation or whatever the case is. Now, again, we're not talking radiation loads. We're just talking about general environmental loads itself. So that's some of the criteria that we get for Category 4. So that would be the case where buildings and other structures, the failure of which could pose a substantial hazard to the community. Okay. It also includes buildings and other structures, including but not limited to facilities that manufacture, process, handle, store, use, or dispose of such substances as hazardous fuels, hazardous chemicals, or hazardous water containing sufficient quantities of highly toxic substances. So again, we're all talking about threat to human life on those type of structures. Okay, and generally, Category 4 building, it's pretty obvious, when one should be falling in there. You can also have support buildings. Maybe it's, like a FEMA headquarters or something that needs to, be running and then to be able to manage disaster response. You could classify a building like that as a Category 4 because it has to be up and running. Okay, even though it may not be, a threat to a large number of people if it's failed, but it does serve a purpose. So again, you got to use your best engineering judgment to kind of assign these. Okay, going back up to, so those are the two extremes. You've got kind of your Category 1s, which are your ag barns or low risk, to Category 4, which are your essential buildings or high risk. Okay, Category 3 then is buildings and other structures, the failure of which could pose a substantial risk to human life. Now, the key word here is substantial. Well, how do you define substantial? Is it number? Is it long-term effects? It's kind of a hard one to kind of quantify, and so it's a qualitative term that again comes back on your engineering judgment. They do give you a few extra categories to kind of help you further divide this down, such as buildings and other structures not included in risk Category 4 with potential to cause a substantial economic impact and/or mass disruption of day-to-day civilian life in the event of failure. Okay, so maybe it's not necessarily the loss of life, and now it's the impact to the human life. Something that took out, say, the subway system in New York City might be considered as a Category 3. Okay, that if it's shut down, then people can't get around the city to perform their tasks or do whatever. That would be kind of a Category 3 kind of thing. You can also say buildings and other structures not included in risk Category 4, including but not limited to failures that manufacture, process, handle, store, or dispose of such substances as hazardous fuels. So again, you're starting to see that same statement come around here. Okay, but the statement is that it's a risk, but maybe it's not as big of a risk as what you would call a Category 4. Maybe it's not as toxic. Again, open to interpretation, open to judgment on that as well. Okay, so that's your 1, 3, and 4. So 3 is more of a services, 4 is more of a direct impact on human life. If you can't find a good category for all of these other to fall into, you're back in 2. Okay, so 2 is kind of the default, the catch-all for all of those. So that's our first thing. So everything that we do is going to come back to how do we define the importance of this building, the risk category of the building. So we'll always have this 1, 2, 3, 4 on our structure. So, a hotel might fall in as a Category 3, but, a mega convention center, super high-rise building might fall into Category 4. It just kind of depends on the nature of the circumstances of the building that you're designing. So anyway, that's the risk category discussion. Okay, the next one is similar, okay, and it bases itself off of these particular values, okay? And so in all of these calculations, we're going to define an importance factor, I, in some way, okay? So it's kind of the importance of the structure, if you will, okay? And you'll notice that factor ties into Categories 1 through 4. Okay, so these come out of Table 1.5-2, so we're in the same section of ASCE 710 for this, okay? But what you'll notice is that the importance factors now change depending on the type of event. So let's see if I can clear this up a little bit. Our focus is a little out of focus. See if that maybe a little bit better. Okay, let's try that. Okay, so it's broken into 4 categories. Okay, the first one then is a snow importance factor. So if you're looking at a snow event and you're a Category 2 building, your factor is 1.0. In fact, you'll notice that all of the tables in ASCE 710 are calibrated to Category 2, that their importance factor is rated as 1.0 for a Category 2 building. Okay, whereas for snow, if you go up to, say, Category 3 or Category 4, you could get a 10 or a 20% increase, 1.1 and 1.2. Okay, so this is where you would find your snow importance factors. Okay, there are ice importance factors because ice behaves a little bit differently, and you'll notice that those factors are a little bit different as well. In fact, it goes from 1 to 1.25 to 1.25. You'll notice that the Category 1 for our low risk categories, the values actually get less than 1. So you can actually reduce the loads because they're not as important. Okay, and the savings are fairly substantial. It's about 20% on all of these. Okay, for wind, this is a change to this version of the code. It used to be that this table had different values for wind based on your category of buildings. But what they've done, and I'll show this when we get to wind, is they've actually incorporated these values directly into another table. So that's why everything is now calibrated as 1.0, and it allows you to know that, oh, if I need an importance factor, I have to go to this table, but wind handles it a little bit differently. And I'll explain that in the next videos when we get to those, okay? And then finally, we have our seismic that's the same way, that it's calibrated for 2, but 1 and 2 are about the same, and as you get into 3 and 4, you can see that you get substantial increases. So, a Category 4 building under a seismic event is going to have a 50% increase in the loads on it, just because of, again, part of these importance factors are coming from, our certainty and the behavior of a structure under those loads. That seismic events are highly unpredictable, so we need a bigger uncertainty. Kind of like what we did with the load combination factors in one of the earlier videos, that we apply different safety factors to different types of loadings. That's kind of what's happening here with these importance factors. Okay, now, like I said, for the wind case, this I is now combined into the wind speed maps, and I'll show you that when we get to the wind. Okay, all right, the last piece of information that we got to kind of look at then is what we call the exposure categories. Okay, and exposure categories is kind of the susceptibility based on geographic location to certain events. Okay, and what they do is these exposure categories take into account the height of a structure and its surrounding surface conditions. Now, is your building in amongst a bunch of trees, or is it out in an open field, or is it on a shoreline with unimpeded flow over open water, say for wind? Buildings on the coast are susceptible to hurricanes because of this exposure category. So now, kind of like what we saw with the importance factors, if you're in doubt, the most common exposure is going to be listed as C. Okay, but all of this is exposed in ASCE 710 up in chapter 26. So all of these definitions come from this paragraph, 26.7.3. So like I say, if you're, I think it's pretty legible, but if you're having a problem seeing this, pull out your code and take a look at it, and you'll have access to this. For my students, we've got digital copies of this for you to be able to look at. So for that being said, there are only 3 exposure categories. It's B, C, and D. So we'll start with B, and this is for buildings with a mean roof height of less than or equal to 30 feet. Okay, and we'll explain mean roof height here in a little bit. So this is basically, a 1 or 2, maybe a 3-story structure or smaller. It has to be in order to be able to expose B, okay? And then exposure B shall apply where the ground surface roughness as defined by surface roughness B prevails in the upwind direction for a distance greater than 1,500 feet. Okay, for buildings with a mean roof height greater than 30 feet, exposure B shall apply in the upward direction for a distance greater than 2,600, or 20 times the height of the building, whichever is greater. So exposure B. So if you've got a building that's and what that's saying is, what we're trying to not have happen is, let's suppose, and we'll use the case of, I have some structure that's here, okay, and then I have, it's sitting in amongst the woods of this thing. Then if the wind is coming in this direction, the wind is being impeded by the trees that are happening in this region. Okay, whereas if instead my building was sticking up above the trees, then the wind that's happening here would be a different exposure, because now there's if you imagine kind of a basic line like this, there's nothing stopping the wind from hitting the building on the upper parts here. So you might get a different exposure on the upper part, but a different, but something's smaller down on the lower as a result of that when we get into those. So this is why they're talking about the roughness conditions. It's, what are the objects around doing to help change the effect of the environmental effect that's coming in at you. Right? It really affects wind, and it really affects snow. Okay, and we'll explain why when we get to those different topics. So we want to kind of be careful when we're looking at this, especially when here I've drawn it as trees. It could be other buildings or something. And so one of the things that you have to keep in mind when you're defining the exposure is, if you're looking at a 50-year life of a building on average on this, will the exposure be the same over the course of that 50 years? Okay, I'm always hesitant to use trees, as a break for my exposure factors, because it's really easy for somebody with a chainsaw that buys the property next door to you to come in and clear cut the land and take the trees out, or to demolish the buildings or something. And all of a sudden, when you thought you had an exposure B, and your friendly neighbor comes in to make improvements on his property, cuts the trees, clears the buildings, all of a sudden he just moved you to an exposure C. So you're kind of, B is a hard one for me to justify unless it's, in certain circumstances. Now, if I'm in, if I have, say, a bunch of hills or a bunch of mountains or something that are blocking that are harder to move, then yeah, maybe I'll jump down and grab a B. But there's some other concerns that come with that as well. So that's what exposure B is. It has to do with the surrounding environment and the setup for that for a certain distance. In this case, usually it's about a half a mile. Okay, and so for those, okay, 1,500 feet or 2,600 feet, depending on the criteria. Okay, again, we said exposure C is kind of, if it's not B and it's not D, then it's C. Most of the time, this is what I tend to choose, just because, again, a lot of times where I've done my work, exposure B, I can't be assured that 30 years from now that it will be exactly the same. So I design my building for something slightly higher, and that lets me sleep at night. Okay, the last one then is exposure D, and this is the most severe. And this is exposure D shall apply where the ground surface roughness is defined by surface roughness D prevails in the upwind direction for a distance greater than 5,000 feet. Okay, so this is basically a mile, in the upwind, and typically it pertains to wind. Okay, so a mile of clear, undisturbed land. Again, that could be over an open field. That could be back on our picture here, that you're in the middle of the woods and your building sticks up over it and you have a forest for a mile on either side and the wind's coming in, say, from the left or from the right. Okay, you can have different exposures based on directions of events as well. That maybe I'm coming over a mountain on one side that's not going to move anywhere. I call it exposure B, but then I come from over the trees from the west, and that could be an exposure C kind of condition. So your load cases change depending on these environmental loads, and these environmental loads can change directions, especially with wind. Okay, but the one where this one really tends to pertain to this is maybe I have a hotel, that's happening on the shoreline or something. Okay, whether it's a hotel in New Orleans on the Gulf of Mexico, or maybe it's could be even a hotel, say, in Chicago that's sitting on Lake Michigan. It's a big body of water that there is nothing here to block the wind from hitting this building at full force. That's a D factor. Okay, that's our exposure D happening there. Okay, and again, you could have D on one side, and I could have something else when the wind comes from the other direction when we start to define all of those. So those are kind of some of our basic exposure Ds. Okay. Now, for wind, they do have one other little criteria, and this is, I'll give you some warning, that for a lot of ASE 7s, you've got to watch out for these single line guys that happen in several places. I'll try to point them out as we come to it. For a site located in the transition zone between exposure categories, the category results in the largest wind forces shall be used. Okay, so again, what that's saying is that even though our factors are, B, C, and D, it doesn't just go from B and then immediately jump to C. There's kind of this build up or decrease as you move from one to the other, and that's what they're talking about. If you're in that build up area on there, then you have to just use the worst of the two. And most often, those are the factors associated with C. But there are cases where a B case could control, even though a C is a larger load. And we'll talk about those as we start to move through. So anyway, those are some of the major importance characteristics for environmental loads, for importance factors, exposure categories, building categories, those kind of things. Those are the main pieces. So we'll come back to these tables and show how you start to use these when we start getting into the actual computations for our other loads. So anyway, as always, if you got any questions, toss me a comment down in the comment section below, and we will go through that. I'll be happy to try to clarify things, and be sure to like and subscribe to the video. So anyway, have a great afternoon, and we will talk to you all later. Happy engineering.